Hello there. In this lesson, we'll be solving some exam type questions on vectors. Now we are given vector OA to be equal to 3 meters and 30 degrees and vector OB to be equal to 6 meters and 120 degrees. We have to find to the nearest degree the bearing of B from A. We are also to find the length of the vector BA. Now let's draw out the vector representation given. We have OA and OB drawn as shown. The bearing of B from A has been represented by beta on the diagram. From here, on the diagram, we can see that the angle BOA is equal to 120 degrees minus 90 degrees, minus 30 degrees, which is equal to 90 degrees. And this means that we have a right angle triangle for the triangle AOB. Since this is a right angle triangle, the angle A can be obtained by taking tan A, which is equal to 6 over 3, and A is equal to the tan inverse of 6 over 3, which is 2. And therefore, angle A is equal to 63.43 degrees. We can see that angle A is made up of the 30 degrees angle and the angle labeled X. Now to get the unknown value of X, 30 plus X is equal to 63.43 degrees, and therefore X is equal to 63.43 degrees minus 30 degrees, which is equal to 33.43 degrees. Now, how do we get the value of beta, which is the bearing of B from A? We can see that beta and X lie on a straight line, that is beta plus X is equal to 180 degrees. Therefore, X is equal to beta is equal to 180 degrees minus X. And since X is equal to 33.43, beta is equal to 180 minus 33.43 degrees, which is equal to 146.57 degrees, and that is equal to 147 degrees to the nearest degree. Now let's take a look at how we can calculate the distance AB, that is the distance of the vector AB. We can see that we have a right angle triangle and we have two sides known. The third side, which is AB, can be obtained using Pythagoras theorem, that is AB squared is equal to 3 squared plus 6 squared. Note that the unknown side AB is the hypotenuse of the right angle triangle, and therefore AB squared is equal to 9 plus 36, which is equal to 45, and AB is equal to the square root of 45, which is 6.7 meters. Now let's take a look at another question. We are to find the magnitudes of P and Q respectively, given that P is equal to 3, 4 and Q is equal to 5, 8. Now, since we are given P to be equal to 3, 4, the magnitude of P is equal to the square root of 3 squared plus 4 squared, which is equal to the square root of 9 plus 16. And this is equal to the square root of 25, which is 5. We are also to find the magnitude of Q. Since Q is equal to 5, 8, the magnitude of Q becomes square root of 5 squared plus 8 squared, which is equal to the square root of 25 plus 64, and that becomes root 89, which is 9.43. We are also to express Q in the form AI plus BJ, where I and J are unit vectors in the direction of X and Y axis respectively. To do this, we simply take the values given for Q. The first value, which is 5, takes the unit vector I, while that of 8 takes the unit vector J. Therefore, Q is equal to 5I plus 8J. And finally, we are to find the magnitude of the vector Q minus P. To do this, we first find Q minus P, which is equal to the vector Q, 5, 8, minus the vector P, 3, 4. And subtracting these values, we have 2, 4. Now let's find the magnitude of this vector. That is the vector Q minus P. And this is the square root of 2 squared plus 4 squared. And this is equal to 4 plus 16, which is equal to root 20. And root 20 can be expressed in decimal to be equal to 4.47. I hope you now have a feel of how the exam questions will come. Get more questions and practice more. Bye.